Yeah, so um, when I'm doing these web things that I was talking about, yeah, there's lots of dinky things I like to build. Yeah, oh, wait, yeah, cool. Whether it's, something cute like this clock camera thing that I built, or something a bit more professional like this login with link thing that I've been experimenting with, what I really want behind it is just something relatively lightweight, just something that can store data, hopefully give me some real-time sort of behavior, and just make it super easy for me to knock out a front end, because I'm a full stack dev and I want to be able to work right across, like from some React component or something at the front to whatever's happening in the back end. I don't want to have to spend a lot of time on any one part of it because I don't specialize. I'm full stack. So what I discovered was a product that was acquired by Google, which is called Firebase. Many of you have probably heard about Firebase. Some of you probably use it like we do at DC for the notification machinery that they provide. And there's several other things that they give you as well. But what I really like about it is the real-time database with real-time, sort of WebSocket style updates about data that's in the store. And it just makes building any of this kind of stuff kind of trivial. It's effortless. It's so easy. And so I love Firebase, except when I don't. Sometimes, so when I got started with Firebase, it didn't have good offline testing. And admittedly, this was sort of 10 years ago. This was Australia. I was offline a lot because Australia doesn't do internet very well. And so that was awkward. Their authentication machinery, it's gotten better. I recently discovered, after building a system for login via email, I just discovered that Firebase actually provides login via email. So totally usurped me on that. So awesome. That's really good. But you still have to pay Google for the product. And so, whether you want to do that and then the limitations they put on it and stuff, it's, yeah, maybe paying for Firebase isn't the thing you want to do. So I came up with this idea. I wanted to build this thing that was sort of like Firebase, but like I'm an opinionated guy. It was going to be my opinionated version of Firebase. And so what I needed was a data store that was evented so that I could communicate changes to users when they happened in the database. And thus began this ridiculous freaking rabbit hole of looking at all of these different solutions for how you event a data store and get information about it as it changes. And everyone says, oh, Meteor has been doing that for ages. Meteor uses Mongo change feeds, which tells you when someone reads or writes something from the database. And I mean, that's the start. But what I get with Firebase is I get a query that I can describe, and then I can find out when records inside that query change. So I don't have to look at an entire log of every change that happens to a database or even a table, and try and guess whether that fits inside the query that I'm doing. Like at that point, am I starting to reinvent the query machinery that I previously put into the database? Like, it's the thing that does the query. Why am I trying to guess whether or not a change that comes through a change feed fits inside the query that I'm trying to do? People say, have a look at Superbase. Superbase does the same thing. It's just Postgres change feeds instead. And so I was ready to give up. I was like, do I write this myself? Like, how do I, clearly all of the databases that exist have these change feeds and can tell me when something changes, but they don't have a concept of a query changing. It's not the way databases work these days. Someone's going to have to fundamentally rethink databases to give me this machinery. Has anyone done that? Well, someone did rethink databases, and that's why they called it that. So RethinkDB is engineered from the ground up to understand change sets and the evolving state of the database, and to give you information about that as it's happening. They originally wrote that sort of stuff so that they could efficiently propagate the database when it's sharded. And that's something lots of databases do. But as part of that machinery, there's now a concept in this engine of a live query and changes that are happening against that query. And so the ultimate result that we're aiming for here is something like this. A set of information that we have where we can sort of shove new records in. We can tell the count of the records. We can add and delete records. Theoretically, we can sort of paginate through them and stuff. That's the desired result. The way that we do that, so RethinkDB has great Ruby support, and you can see if you have a look at their documentation, you can see, it's super easy to connect to the database, to create tables and connect to them and stuff. And the stuff that I'm talking about, the change feed stuff, is all in here as well. What I am more used to in this kind of space is the sort of evented behavior in Node.js. And so the code that you'll see here is actually, it's JavaScript instead, but the principle is very much the same. You can do the same thing in Ruby. It's just slightly easier to read, I think, in JavaScript. So literally, you're talking just importing some machinery that Rethink uses to communicate the different things we're trying to do. We're trying to talk about tables. We're talking about rows. We're talking about sorting order in descending. The reason why we have these primitives that we're importing through code rather than, a sort of an SQL style, just like express it purely in text, is that we're going to push a fairly sophisticated structure of data through to the server, and it's going to run it. So it's not something that we can describe exclusively in text. And so what you'll see here is like we're building objects of like the descriptor, the descending sorting of, no, sorry, that's a descriptor for ID, and tables we're describing through helpers like this. So we can build up a complex query with this kind of invocation. And then the thing that I'm really excited about is subscribing to the changes that happen. So that's what we're doing here. And we pass in some options and we run it, and then we respond to repeated invocations that happen for our helper, our callback that we pass in. So I've got that collapsed at the moment. We don't really need to see that, but I'll get back to that in a minute. So there's some things that are similar to change feed behavior in other things. So if you're looking at Mongo and you're looking at the change feeds that are available there, you can ask them to give you the full record that's changed, and that's nice. We certainly have that here. That's sort of the default behavior, but it gets a lot more interesting when we start to look at things like this include initial. So when you subscribe to the change feed for a database or a table in, say, Mongo, you subscribe from a particular point in time, or you can use a cursor and you can, change the point in time that you're subscribing to. What you can't do is say, what you're forced to do is to go and query the table first, get the current state, and then start following, and then start watching for changes. What this include initial does is it gives you a kind of a seeding process where once you start subscribing, you get all of the existing records as initial records before you start getting changes. And so you can run your entire state, your awareness of this particular table can run entirely through this change feed. It doesn't have to be this hybrid thing where you say, get the state and then start listening. So that's incredibly powerful. That gives you confidence that there's never any records that sort of maybe went in or came out in the gap between those two, which is super handy. So the subscription that we have is quite a complex, rich kind of thing. Because it's a query, there's this sense of, it's a little bit like a materialized view. You have a set of records that you're aware of, and it's like an ordered list of records. And so the first thing that you want to know is, if for any change that you see that happens, say an add record happens or a delete, you want to know where in that set of records that new record has come in, or the old record has gone out. And that's what this include offsets is all about. So that gives you a sense in that range that you've asked for. As you can see, I've done this limit 10, which means there's 10 records that I expect to be thinking about, and that include offsets will tell me where a new record came in or where a new record came out. So I can always keep up to date this kind of sort of materialized view that I'm maintaining. Including types is how we ask for what the messages that we get, the update messages we get, whether it's an add or a remove, or if it's an update to an in-place record. And then states is really interesting, because that seed cycle that I mentioned earlier, while we're getting those seed records, we're setting up our state. But later on, we'll be in a state where we're just processing changes. Now, it's a little bit complex, because if the system is streaming us changes, someone can at that moment jump in and smash us with a new add or update or whatever. And so we can theoretically get more complex information. So what the state information gives us is, you're currently in the initial phase where we're propagating new records to you, and then you get a ready message, and that tells you there will be no more initial records. You may have got some updates previous to this, but as of now, you will only get updates. And so that helps you keep track of the sort of, you can have some confidence about the state of your sort of materialized view. It's kind of finished once you get that ready message. And so that's quite complex. And so you can imagine that the code to kind of understand that, reason about that, and put that into that sort of materialized view is a little bit fiddly. And I'm really glad I didn't have to write it myself. The RethinkDB guys actually started a project that does something a little bit like what I'm doing. It's called Horizon. And so I took advantage of the joyful thing that is open source, and shamelessly cannibalized their code to make sure that I was doing this correctly. Because my intention is to maintain a sort of a materialized view on the server and then propagate that out. Something a little bit parallel to the way Firebase works, but in my own sort of idiosyncratic way. And yeah, that's kind of how these change feeds work in RethinkDB. There's a couple of idiosyncrasies about offsets and stuff. So you can't do offsets in perhaps the way that you would expect to do them. So it's much more, it invites more of a sort of a cursor approach, where you sort of say, I'm looking for all the records after this record. I want 10 records after this record, rather than, I want 10 records and then I want offset 10 and the next 10 records. And that's a limitation to do with the underlying machinery of how Rethink works. It has this concept of eager streams and not eager streams. And it's quite complicated. It's to do with the engineering of how they propagate this information through. But yeah, there's documentation on that sort of stuff. And if you find that you're hitting some unexpected sort of behavior, it's easy to find out exactly why that is and how to correct it. Yeah, so I really feel like this is machinery that gives us something that in the modern web world, this does something that traditional databases simply can't do. And something like Firebase for light projects, for the dinky junk that I like to play around with, is almost always enough. But if what you have is more targeted, you don't want to use Firebase for some other reason, Rethink is here. It's the company that started it is no longer around, but there's an open source community supporting it. So support for it, new features and stuff is not going a million miles an hour like it used to, but there is still a community supporting it. And really, in many respects, it's the only technology sort of going in this direction. So I think it's definitely worth looking at if real-time events like this, real-time data, is a thing that you think might serve your use case. Any questions? Wow.
I don't have any questions, but I will look into it.
Your mic is really low, I think.
Sorry, sometimes.
I can hear someone muttering in the background, but
How's that? Any better?
We'll lean in to listen. Oh, it will write it out.
that'll be good too.
Chris will write it out. Any question while Chris is writing his question out?
Oh, not really a question, just more an observation, so to speak. If you're looking for other alternatives to Firebase, there's one that seems to be gaining a little bit more traction around that's also quite active. It's AppWrite. I'll throw a link in the chat.
Awesome. I've never heard of that. And so, yeah, that'll be super useful. Oh, wait, AppWrite. I did look at this just recently.
Yeah, full disclaimer, I've only barely looked at it myself inside the last week. So I'd rather use something that's not Firebase because Google, but yeah.
These guys are brand new. I just saw this come through as a bleeding edge kind of thing. But yeah, definitely worth keeping an eye on. Anyone else?
How's the mic now? All good?
That's way better.
Yeah.
The other thing I wanted to ask about was, are there any GeoJSON features around RethinkDB, like how MongoDB does really nice geolocation stuff?
There is actually. I didn't get the feeling that it's quite as sophisticated as the Mongo stuff. Mongo has long had a really good line in that stuff. But yeah, my impression is that there is at least basic support for that stuff, like baked into the database. Like you don't even have to go outside. Anyone else? Thanks for your time, then.